In this episode, we're going to talk about how to teach a material handling robot. We're going to use the set tool command and we're going to establish the U tool in the virtual robot. We're going to talk about how to use the teach panel and modify the different attributes inside the teach panel. We're also going to use the grab and release command, and we're going to show you how to reorder points and use the copy and paste functionality inside of the teach interface. We're then going to show you how to run the robot task. So here we go. Here's a helpful hint. If you notice, you don't see my robot locations. That's because what I've done is I went to View and I went to the View modes. And I can turn on and off axis systems and planes. So if my work cell looks too cluttered with all the robot paths, I can turn them on or off using this setting. So it keeps your work cell from looking too messy. Okay, so what I've done is I've consolidated my layout a little bit, and we're going to add another robot in here to perform some material handling operations before we have this FANUC robot perform the welding. So what I did was I just basically moved the objects into this configuration, and then I created a state around it. So this is my new configuration, and this just makes it easier for me to have another robot in here to perform the material handling operation. So I'm going to exit 3D simulation, and I'm going back to my bookmarks. And so I had made some bookmarks containing several different robot models, and one of them is a universal UR16. And so in my catalog, I want to use this UR16E, and I'm going to take it and I'm just going to drop it in here. The other thing I did, if you notice, is I shortened one of the pedestals and I just dragged it down. This pedestal you see goes underneath the floor, but you can resize the pedestal inside of SolidWorks, no problem. Once you realize, of course, what the appropriate height should be for it. Because as you know, this is a validation exercise. And so robot risers come in all shapes and sizes. And so you can actually just resize this according to what your findings are from the simulation. Okay, so, and I'm also going to point this robot over in this direction. Now I'm going to double click and make sure that I am at the appropriate angle. Okay. I'm also going to bring in a gripper that I designed in SolidWorks. And this gripper has been processed inside of Robot Programming Essentials. In another lesson that you'll find in the series of videos, we've added kinematics to it, and we also created a port on it. One is a base port to attach to the faceplate of the robot, and the other one is a port that gives us the tool center point. So those are found here. Okay, so going back into 3D simulation, I'm going to mount the gripper onto the UR16 robot. So using the set tool command again, and let me get rid of my widget that's still running from the... here we go. Okay, so I'm just going to pick the robot and pick the gripper. And it automatically snaps according to the configuration that you have on the port. And so in this port, it looks like it's a good location, and I'm going to say, okay. So now I have the gripper mounted onto the robot. And so when I jog this robot, it'll show me that tool point. that was on the gripper device. Okay, so let's put this back in a reasonable position. Okay, so I'm going to use this as the home position for the UR16. I'm also going to jog the Fanuc robot and put it at a home position that I can use. So I don't want a home position to be over the tool. We want it out of the way. So I'm going to put it somewhere over here so it's clear of the other robot until it receives a go to weld signal. All right, so just bring this in a little bit and we'll just call this our home position. And I'm going to have the system remember this by creating a new state. Okay, so here's a helpful hint. If you find that your pick options have changed and you no longer get a whole object when you pick, you can tell the system to display your application options. And here is a resource product selection. So when you invoke this command, it'll change the pick level. So I can either update this existing state or I can create a new one. So what I'm going to do is I'm just going to create a new one, and I want my pickup and drop off tables to be blue. So I'm going to create a new state. I'm going to make sure I have all the objects considered. I'll get rid of the old one. Okay, so I've got my furniture laid out in my work cell, and I've applied some colors to some stuff. And so I want to teach this material handling robot. The first thing I need to do is to get the gripper mounted on the end of it. Okay, and so I'm going to show you set tool again, but this is going to be just a little bit different. So when I click on set tool, I have to pick the robot and then the gripper, and it mounts it right on the end. And if I want to, I can adjust it. I need to. And so what's different is this gripper has a degree of freedom. Unlike this torch, the gripper has a degree of freedom. And so it is classified as end of arm tooling. But the difference is that we want the robot to control that gripper. In other words, when we teach the robot, we want to teach the gripper too. So we're going to combine, they're going to be combined in the same motion group, and it's going to be an external axis of the robot. That way, when we teach the robot, we teach the gripper. One other notable item is, besides end of arm tooling, it also has capabilities for the robot to have other types of kinematic devices within its control, such as a workpiece positioner. You could put the workpiece mounted on a positioner in front of the robot and have the robot control that positioner and have the positioner weld while have the positioner move while the robot is welding. Or you could have the robot mounted on a rail or a gantry. So I could have the base of this robot mounted on top of a rail, and the rail could move it left and right, and the robot in the session would control that rail that the robot's mounted to. So it's pretty slick. Also, when I click OK, this is also going to inherit the tool point that we put on the gripper. Remember when we modeled the gripper and we went into the device building application, we added a mount port and a tool port. And so that tool point is going to be invoked when it's mounted to the robot, and I use a command like jog, and I click on the robot, and there it shows me that I have a tool point that will control this robot when I'm in the session. So this is how I'm going to program this robot. Okay, so since I'm in jog, I'm just going to move this robot to a position that is out of the way, so to speak. We're just going to take it and move it somewhere so that it's out of the way of the other robot. So maybe something back, and I'll move it over here. So this will be my home position for this robot. This is where it's going to start from. What I'm doing is I'm configuring what my starting point is going to be for the session. So when I run a robot program or I run a simulation of the cell, it's going to have a beginning point. And obviously, it's going to show you when the robot's in singularity and when it cannot reach a position. So I'm going to have to get this someplace it can reach it. Something like that, maybe. Oh, I'm in the fence. Okay, so I'll put the weld robot over here. Okay, so I have a fixture in place to drop off. I have a part and a fixture that I'm going to pick up, and the robots are at home and the gripper is open. Let's check. Okay, yeah. So when I say jog the robot, I can jog the robot or I can jog the gripper. Okay, so it's open. So what I'm going to do now is I'm going to save this. And this is where I go to my simulation states. Way over here, remember simulation states. So this is going to be the beginning for my material handling. So this is for my pick and drop. So this is the initial state for when I run the robot program for picking and dropping that part off. Keeping in mind that I'm going to have another initial state when I program this arc welding robot, and it's going to have this control arm and fixture over here. So when I start programming this robot, its initial state is going to have the part inside of this fixture. What I'm going to do with this robot is let's look at the teach interface and let's program the robot to pick it up from this fixture and drop it off to the other one. Okay, so here's my teach interface. The first thing I want to do is I'm going to program in a point for the home position. Now there's going to be two of these. One's going to be at the beginning and one's going to be at the end of the sequence. Okay, so the first thing I want to do is get the robot over the part in an attempt to approach it. So right now I'm just really estimating, because what I really want to do is find the pickup point and then back my other points up from there, because I want to come in I want to come in on the part straight and I want to leave straight. Okay, there we go. So there's a decent pickup point. What I might want to do is check that I'm square with the part. And one way to do that is to check my values here. And this is assuming that this part is also square with the world. And this will give me the best approach. Okay, so I'm going to record this. This is going to be my pickup point. So I record my pickup point. Now I need an approach and a departure. So I'm going to go straight up. Now remember, 3 is my pick. I'm going to record 4 and 5. I'm going to move 4 up because 4 is going to be my approach to pickup. This is home. It goes at the end. Okay, so 3 is the pick and 5 is the depart. So I'm going to add another point on 3. Only this one's going to close the gripper. So I'm going to look at the jog panel and tell the gripper to close here. Now I'm going to modify this point. And also on point number 5, the gripper should be closed. So again, I'm going to modify the gripper to close, and I'm going to modify point number 5 with a closed gripper. So as we approach, and then we move into the part, and we close the part, and then we move out. Here's a helpful hint for you. When you program the pickup point on your part, ideally you want it to be the same everywhere, no matter which fixture the part's in. So what we can do is when we program the proper pickup point, we can copy that tag point location. Once the location has been copied, we can create a new tag group. Now this tag group is going to belong to the control arm. So the first thing I'm going to do is I'm going to copy the pickup location and I'm going to paste it into the tag group. Now that that's completed, I can simply attach that tag group to the control arm. So now that the tag group belongs to the control arm, everywhere the control arm moves, the tag will go with it. Okay, so now I know that 0.7 is where I'm going to institute a grab on the control arm. So what I want to do is to be able to find the control arm in the tree so that I can manipulate it when I institute the grab. So over here on the side panel, and this is where you have all your decision-making tools for your task. You can add parallels, you can add timers or decisions. You can add wait statements, you can do loops. So there's a lot of really sophisticated programming types of operations that you can do inside of your tasks. But what I'm going to do is I'm going to come down here and I'm going to use a grab. So right here at point number 7, it's a pick and drop with this gripper. It names the gripper for me. And now it needs to know what is the object that I am picking up. And when I pick that object, I want to make sure that I only get the object that I mean. Make sure that only the control arm is there, only what's meant to move is going to highlight. Also consider, remember, that we have this in a manufacturing product. If it's a resource or something else, the pick is probably not going to work on it because the object is not classified correctly. So I say okay. All right, so going back, see now that I've instituted that grab, now when I move anywhere in the program, the control arm is going to go with it. Okay, so now that I've grabbed the control arm, I'm going to then move it over to this drop-off fixture. And see if I can get a hold of Command 1, and I'm just going to rotate this over in one big joint move, and I'm going to get this control arm over this fixture. And so again, I'm just going to get it in the general vicinity, and then I can touch it up later. Okay, so when I adjust the values, again, I'm square with the fixture. I just need to make sure that my ingress and egress are correct. And how I'm going to do that is I'm going to, again, go down to the fixture with the part, and then I'm going to work it backwards from there. Okay, so it looks good left and right and up and down. So I'm going to record this point. Okay, so number 8 is where my drop location is going to be. Then I'm going to open the gripper. Sorry, first of all, I'm going to release it. So I'm going to come back to the side panel, click on release. And I'm just going to use this generic release all because I don't have a lot of picking and releasing going on. There's only one, so. Now, I can program in the ingress and the egress locations. So I'm going to record them both. There's one. There's two. So one's going to go before it approaches the fixture. And the other is going to go after the release. So the robot will have the control arm in its grasp. It will come over to here. We'll move into the fixture. And I still need to open this gripper. So I'm going to program one more position here. And this one's going to have the gripper open. So now the part's been dropped off, so the gripper remains open from here on out. And then we'll send the robot home. Now, I want to run this scenario to make sure that I did it properly. But don't forget that there's an initial state. If I click on this run button, everything's going to go to an initial state. If I have more than one initial state, I need to make sure that the correct state is active. So I need to go back and make sure that when I left, that this is set as active. And by default, it is because it's the only one. But when you have multiple states, you'll have to make sure you come back to the state and set the initial state and take your state and set it as active. Otherwise, the beginning point of your simulation will be completely wrong. Okay, since I'm here, I can just apply this state right now to put everything at the beginning. And I can run this in through the teach interface because there is a play button here. And let's see how I did. Okay, pretty good. If I'm not happy with anything, for instance, a lot of these moves, for instance, from right here, I'm moving down into a fixture. And I need to use a linear move. This move needs to be a straight line when it goes into that part because you saw how close the gripper is inside. So what I'm going to do is when it moves to number 3, I want that to be an absolute straight line. So I'm going to change the motion type to linear. So now it will calculate a straight line between those 2 points. Then it grabs. And once it grabs the control arm, it comes up to here. Again, it should be a straight line. So this is the part where you'll want to dress your motion types to make sure that as you moved into the fixture, you want to make sure that the robot's interpolating a straight line motion. Because if it doesn't, what that's going to do is it's going to insert some curves during the robot motion, and the robot's not going to enter the fixture the way that it needs to. And also, you can do these by using the control button and selecting multiple selecting multiple locations, and then change the property on them. And there we have it. So now that you have the material handling robot programmed, we can program the arc welding robot, and then we can sequence them in the sequence editor or by using I/O, and we'll show you that in the next chapter.